This is the Earth Changing Climate Sim, and I just moved my picture a little bit out of the way so you can see. And you'll remember from the directions that we want to use the graph in this part of the sim. So we're on the human activities part and we want to use the graph. So the first thing we're going to do is we're going to explore carbon dioxide. So I'm going to hit play. I'm going to move that up to 4 times. And we're going to see what is the effect of carbon dioxide and how it's connected to population. So I paused it at 30. And as I saw, just with our normal population, with humans doing their human activities, that the temperature on Earth's system increased. And that's kind of a weird way to say that, but the temperature increased. And let's see, if the temperature increases, what do you think is happening to the amount of energy absorbed? So I can click here and I can see that, but you probably already knew that if the temperature is increased, the reason it's happening is because the amount of energy is being absorbed by Earth's surface, and that makes the temperature go up. And we know that if the temperature is increasing, that the amount of surface ice is going to decrease. And we can see that when we click here, that it started off, just at about 50% of the Earth's surface, 40 to 50. But then once the population of people started doing human activities, that the ice started to melt. And this is similar to what we're seeing happening right now on our planet. Human activities have been increasing the amount of carbon dioxide in the atmosphere. Okay, so now what we're going to do is, what would happen if we just decrease Earth's population from 7 billion down to 1 billion. And I'll hit play. And we'll let this run until about 60 seconds. And we'll see what happens. So it looks like temperature is staying, it's kind of staying similar, the same, but it's kind of dropping down. Let's just look at one thing at a time. So carbon dioxide is the gray line and the black line is the temperature. And so when we started, the temperature was higher and it's dropped down about 2 degrees Celsius. And the amount of carbon dioxide in the atmosphere went from about 380 parts per million, and it's dropped down now to 300 parts per million. Okay, so what happens now if I increase the population all the way up to 12 billion? And if you already explored this, then you're going to already know, but let's just look at this just to see together if you had the same findings. And so, oh yeah, you can see that it's really, it reached its maximum carbon dioxide. So let's see what happens now. So I'm going to pause that. I think that's about, 90 seconds was back here. So I let it run a little longer. So the more people there are on our planet, then the more carbon dioxide. But that should also be noted that it's more people doing these human activities. I don't think we should get rid of all the people on our planet. Like we have 7 billion right now. And I'm not saying that we should get rid of 6 billion people. I don't think that's true at all. But it's more just a matter of if all the people continue to do the human activities, that's going to continue to increase the carbon dioxide, which seems to have an effect on the amount of energy absorbed by Earth's surface and the temperature. And then also the ice has, according to the sim, it's dropped down to about 10% or 0% covering the surface. So this is some interesting stuff that we've figured out using the sim. There definitely seems to be a connection with the population and carbon dioxide. So on this table that we were looking at before, you could jot down some ideas here. When you increase or decrease the population, what does that do to the carbon dioxide level? And so let's quickly collect data for these other parts and see if we see other trends that are similar to this or things that are different. So I'm going to go through this pretty quickly since some of you already explored it, and we'll see the results together. Okay, so let's reset this. And this time we are going to be in the graph just like last time, up to 4. And we're interested this time specifically on combustion, like what exactly is happening to the temperature based on combustion. Okay, I paused a little too soon. So now what I'm going to do is decrease it down to none. So that's the population staying totally the same, but the combustion per person is actually dropping down. And I'm going to hit pause again. And then I'm going to move combustion all the way to high and hit play. And I'll stop it at about 90 seconds. Okay, so yeah, this is interesting. For the first 30 seconds when we just had regular human activity, the temperature was increasing. Let me put carbon dioxide so you can see that. The carbon dioxide was increasing. And then once we changed the amount of combustion per person down to 0, then things leveled out and the temperature didn't keep rising. What's interesting though is it also didn't drop down. It seems like the carbon dioxide changed a little, but we saw this in the last time too. It didn't go down by very much. Like, it just kind of seemed to plateau. I mean, it drops a little, but not significantly like you see when you move the population up at from 60 to 90, that the amount of carbon dioxide, it keeps rising. And so we can see here that by decreasing the combustion, the carbon dioxide doesn't really seem to leave the atmosphere very quickly. I wonder how long you'd have to run it for the carbon dioxide levels to drop down to 200 parts per million. So even though the more combustion isn't happening, the stuff that was already in the atmosphere continues to be there, continues to redirect energy that wanted to leave Earth's system. So if we wanted to decrease the amount of carbon dioxide in the atmosphere, we'll have to figure out a way to do that. So in the next couple of lessons, let's take a look at how we can change the amount of carbon dioxide in our atmosphere that's already been there and see what kinds of things maybe we could do. Okay, so let's switch gears, and now we're going to take a look at methane in this column, and we'll look at population again, and then we're going to look at livestock per person. All right, so I'm going to reset it and move it to the graph, hit play, and I'm going to speed it up to 4. And this time we're specifically interested in methane, which is this turquoise line. And we're going to let it run for about 30. I'll pause it. It's a little bit past there. That's fine. And this time I'm going to decrease the population down, hit play, let it run till maybe 64 this time since I went to 34 last time. And then we're going to take the population and move it all the way up to 12 billion. And we can see, it's a similar trend to what we saw with carbon dioxide. It's a little different, but we can see that's happening there. I let it run a little longer so we could see this line. But we can see that at the beginning, with our population just doing normal human activities, that the methane level was increasing. And then once we decrease the population down to 0, the methane level in the atmosphere did start to drop down to about 240 parts per million, but it didn't get back down to 200 parts per million. So I wonder how we could lower that down. And then once we increase the population to 12 billion, it just spiked up to 540 parts per million. And we can see that all the surface ice is gone. The absorbed energy is just really high. And we can see that the temperature has also spiked to 27.6 degrees Celsius, which is so warm that that's like the Eocene period in Earth's past, when even the Arctic was a swampy, warm area for warm water animals, which didn't work very well for our polar bears or our penguins down in the South Pole. Okay, so the next part, what we want to do is we want to look at livestock per person, and we want to see how that affects the amount of methane in Earth's atmosphere. So let's reset it. And this time we'll leave the population at 7 billion the whole time, and then just change one of the human activities and see what methane is going to be affected by that. So I'm going to hit play. I'll move it up to 4, and we're looking at methane again, and we're interested in the temperature and the surface ice. So I can see that it's starting to drop just like we saw last time, but this time we're going to change one human activity, which is livestock per person. And we'll see if that has any effect on the amount of methane gas in the atmosphere. So the first thing I'll do is I'll move it down to none. And you might think, like, what are humans using livestock for? So for meat from cows and sheep, and we reached the max. Forgot to hit pause. And then also livestock is raised for wool or leather, different things like that. So there's lots of things that humans use livestock for. So it looks like when the livestock per person was decreased, like, look what happened to the methane level. So what we've just discovered from this is that clearly there's a connection between livestock and the amount of methane in the atmosphere. We know that methane is one of those gases that can redirect energy that's on its way out of Earth's system. So we'll need to explore a little bit more to find out what methane is, how it's connected to livestock. Okay, so the last thing that we want to do with this one is we want to move the methane producing livestock. There's some connection there up to high. And I think we need to prepare ourselves that the ice might have to go away. We'll see what happens. Yeah, it's dropped down to 0%, and the temperature is rising. The level of methane is rising. The temperature is getting up to, oh, that's so warm, 25 degrees Celsius on average, which means some places are going to be really hot.